So let A is equal to consisting elements 1, 2, 1, 3, 5, 7, 9, 11. So then the number of subset of A, then the number of subset of A which is equal to. Okay. So already you know that formula for the number of subset. Suppose set A has set A n of A, set A as n number of elements. So then the number of subset of set of set A is given by 2 to the power of n of A. N of A is the number of elements in the set A. So here number of elements in the set A. How many elements are there? There are 1, 2, 3, 4, 5, 6 elements. Okay. So n of A is 6. So therefore, this is nothing but 2 to the power of 6. Okay. That means it consisting 2 to the power of 6 subsets. Okay. So therefore, this is the right answer. Okay. So write down. So don't confuse. This is 6 to the power of 2. This is 2 to the power of 6. So the formula, we have a formula that is 2 to the power of n of A. Number of subsets is given by 2 to the power of n of A. That is equal to 2 to the power of 6. Okay. So next question, question number 19. Question number 13. A set contain k elements, then the power set of this set contain dash elements. Okay, so that means a set contain k elements. That is, so n of A is equal to k. That means a set consisting of elements k number of elements. Okay, so then the number of the power set of this set contain power set. Okay, so is the number of elements in P of A. Number of elements in P of A. Okay, so P of A is the power set. Number of elements. This is a collection of all subset of a given set. Is it? So power set A is it is a collection of all subset of given set. So how many subsets are possible to write if the set A consisting the number of elements k? It is 2 to the power of k. Okay, so number of subset. Okay, so number of subset. So therefore number of subsets. So which is equal to 2 to the power of k. Okay, so therefore number of elements. So number of elements in power set A is nothing but 2 to the power of k. Okay, so actually this is the collection of subset, collection of all possible subsets. So therefore, each and every one subset is an element of power set A. Okay, so that means so power set A consisting the element to the power of k. Okay, so write down. So question number 14. Question number 14. So if the set A contains 5 elements, then the number of elements in the power set A. Okay, so same. So similar type of questions. Set A consisting, so n of A. Number of elements in the set A is how many elements? 5 elements. 5 elements. So therefore, so number of elements in the power set A. Number of elements in the power set A. So we need to calculate number of elements. Number of elements in power set A. So that is nothing but so 2 to the power of n of A. So that is nothing but 2 to the power of 5. So this is nothing but 32. Okay. So number of elements is same. Previous questions. In the previous questions, so there are k number of elements. So but in these questions, so particularly k is here what? K is 5. Okay. So therefore, so number of elements of power set A. Number of elements set power set A is nothing but n of P of A. N of P of A is nothing but 2 to the power n of A is nothing but 32. Okay. Next question number 15. Question number 15. So set A consisting, set A is equal to 1, 3, 5. Set A consisting the elements 1, 3, 5. Then the number of elements, number of number of elements in P of A. Number of elements in P of A. Okay. So see here. So it consisting three elements. So n of A is what here? N of A is so 3 elements. Okay. So number of elements in P of A. Number of elements in P of A is nothing but what? Number of elements in P of A. So actually we need number of elements in P of A. So that is n of P of A. Okay, is it clear? So first we have to calculate number of elements in power set. So that is 2 to the power of 3. 2 to the power of 3. This is nothing but what? This is nothing but 8. Okay. So this is the number of elements in this set P of A. Number of elements in this set. So then n of P of A. That is so n of so P of A. So n of P of A. This is the part. So 2 to the power of n of P of A. Okay. So this is the part. So 2 to the power of 8. So this is the part 256. This is the part 256. Is it clear? So write down. So number of elements in set A is 3. So number of elements in power set A is the collection of all subset of a given set. So therefore it is equal to 2 to the power of n of A. So that is nothing but 8. So n of P of A. So then we are taking the number of elements in P of A is nothing but 2 to the power of number of elements in n of P of A. So that is n of P of A. Okay. So that is then 2 to the power of 8. It is 2 to the power of 56. Okay. So next question. Question number 16. Question number 16. Okay. If A and B are non-empty set, then so P of A union P of B is equal to which of the following? That is one in A, P of A will be option B is P of A intersection capital B, and C is P of A is equal to P of B, and D is none of these. Okay. So here A and B are two non-empty sets. So particularly they are not mentioning any element in the set A and B. Just they are given. So A and B are two non-empty sets. Then so P of A and P of B. So it is not possible to predict. So which of the following is satisfied. Okay. So that is so therefore we are taking option B. Okay. So suppose we are here the set A and set B is given. That means some elements are given the set A and set B. So then it is possible to find out. So P of A union P of B, that is power set of A union power set of B. So suppose I am taking two sets to explain this. Okay. So that is set A is equal to let set A is equal to so consisting the element 1. So and D is equal to 2 comma 3. Okay. So then so P of A is equal to what? So P of A is equal to so null set and set itself. Okay. So P of B is equal to okay. So it consisting subset 2 and 3 and 2 comma 3 and 5 itself. Okay, so this is the power set of B. Okay, then just Verify first A, option A. So P of A union P of B. I am taking P of A union P of B. Okay. So that means so element which belongs to P of A or element which belongs to P of B are both. Okay. So this is the limit. So pi. Okay. So the set and 2 constitute limit and 3 and 2 comma 3 and 5. Is it clear? So this is the P of A. So P of A union P of B. Suppose I am taking P A union B. So A union B. Okay. So A union B. So A union B is equal to what? So that is 1 element and 2 3. So observe here. So P of A union B is equal to the power set of A union B. So that is it consists of element 1 and 2 and 3. Okay. And 1 comma 2. So 1 comma 2. 1 comma 2. So 2 comma 3 and 1 comma 3 and 1 2 3 and 1 set. Okay. So there are 8. 1 2 3 4 5 6 7 8. Okay. So if set A consisting n elements, so then power set of A is 2 to the power of n of A. So that is equal to 8 elements. So see here, P of A union P of B is here. Okay, it is given. So here P of A union B is given. So therefore, so come to this. So P of A union P of B, which is not equal to P of A union B. Okay. Similarly, P of A intersection B. So just we are going to intersect these two. Okay. P of A union B. So P of A intersection P of A intersection B. Okay. So intersection, first we will calculate A intersection B. A intersection B is equal to what? The common elements in both. So there is no common elements. So pi. Okay. So null set. So therefore, power set of A intersection B. Power set of A intersection B. So that is also null set. So it has no elements. This is the limit empty sets. There is no elements. Okay. So then the power set of A intersection B. Okay. So no elements. Power set. So therefore, so this is not equal to, so P of A intersection B. P and P of A union P of B. So P of A union B is here. So they are not, so see here. So they are not equal. Okay. Similarly, P of A is not equal to P of B. Okay. So P of A is given. So the set is given. P of A is given. So they are also not equal. So therefore, we are taking options. So it is none of this. Okay. So next question. Question number 17. If 17, okay, if A is the white set, so that is 5. So then P of A has just one element pi. Okay, so that is P of pi, so which is equal to P of pi is equal to null set itself. Okay, so then number of elements of P of pi. So P of pi. Okay. So which is equal to number of elements in P of pi. So see here, it is given that A is the white set. A. So that is set A is white set. So null set. White set is the P of A has just one element, that is pi. So So they are given. So just it consisting one element, so that is fine. Okay, P of A is consisting P of pi is nothing but P of pi is nothing but only the null set itself. So P of pi consisting the only null set. So then the number of elements in P of A. Okay. So see here. So P of A. So number of elements in P of pi. So which is equal to number of elements is 1. Okay. So power set of P of pi is nothing but so one is pi. Okay. Another one is so set itself. Is it clear? So this is P of A. So again we need to get P of null set, that is P of okay. So P of so pi. Okay. So this is the divide. So see here. So one is null set. Okay. So this is one of the subset. And again, so this is one of the subset. So this is one of the subset. Okay. Then both are including both. So pi set itself is one of the subset. Set itself is one of the subset. Okay. And null set. See here. Okay. So it consists in two elements. So therefore n of P of A is nothing but 2 to the power of 2. Okay. So generally, so n of P of A is the null set is nothing but so is it here 2 to the power of P of null set. Okay. So this is nothing but what P of A is equal to 2, that is 2 to the power of 2. It is generally 4. So here we are going to list all the possible subset. So is that what number of elements in P of A. So n of P of pi. Okay. So is the limit 4. So this is also same. So n of P of A then 2 to the power of P of A. So P of A is here. That is so is the limit 2 to the power of n is the limit 2 to the power of 1 is the 2. Okay. So this is the limit 2 to the power of 1. So that is the limit 2 elements. N of P of A. So this is what n of P of pi. Okay. So then n of P of null set is the limit 2 to the power of P of pi. 2 to the power of 4 is the limit 4. Is it clear? Straight up. So here there are two elements. Okay. So P of A consists of two elements. So therefore number of possible elements in P of A is nothing but 2 to the power of P of pi. Okay. P of pi. Okay. So the first is we are going to write the power set is equal to commission of all possible subset. Power set is equal to commission of all possible subset. So therefore I am taking one element as subset. So this is one element. Again I am taking this as a subset. So therefore, so if you are writing of pi, this is one of the element. So then this is the subset of this. Okay. Now I am taking so null set. So itself is a subset. Okay. So and every set is a subset of itself. So therefore I am taking two elements here. This is the subset of every set itself. And so null set is subset of every set. So null set is subset of every set. Okay. So therefore the number of elements in P of pi is the limit 4. Okay. Next question. So question number 18. So if A is equal to so this is element A and B or element B. Okay. So then find P of B. Okay. So there is a small correction in the question. So there is not pi, that is A. Okay, the question to make it correct. So this is not pi, this is A. So element then the P of A, P of A, okay. So P of A is nothing but generally number of element in, so number of elements in P of A. So generally it is 2 to the power of number of elements in P of A, n of P of A, okay. So n of A, n of A. So that is equal to the power of 2, it is 4 elements, it consisting 4 elements. But so here they are not asking how many elements in this set, okay. So just find P of A, that means power set of A, power set of A. We are going to write the power set of A, okay. So power set of A. So this is the equal set A. So that is the consisting element A and one element is B. So this is one element and this one is one element, okay. So we are going to write the power set. So therefore power set of A is the divided. Power set of A is the divided. The first one is, it is a collection of all subset. It is a collection of all subset of a given set A. So therefore, so one subset is one subset. So this is one subset. Okay. And again, this is one element. So therefore, another subset is so this is the another subset. Okay. So next, so null set is subset of every set. Null set is subset of every set. Similarly, every set is a subset of itself. So therefore, so set itself, that is A. So for element B, close the bracket and close the bracket. So observe here. So this is one set itself. This is set itself. And null set. So these are the subset of every set. And so pi is one element. So therefore this is a subset. And B is one element. So this is a subset of set A. So therefore this is the collection of all subset of A is nothing but power set of A. So power set of A is here. So this consisting this. Okay. So therefore option A is the right answer. Option A. Okay. So next 19 question, number 19. So the shaded region gives the figure. So option A is, so B intersection A union B. So option B is B union A intersection C. And option D is B intersection A minus C. Option D is B minus A union C. Okay. So A union C. So figure is go like this. This is set A, set B, and this is set A, and this is set B, and this is set C. This is set C. Okay. The shaded region is go like this. This is the shaded region. The shaded region in the given figure is So see here the first option is B intersection A union B. Okay. So is it reconciled? So B intersection A union B. So observe here. So this is the region. Okay. So consisting the elements in the set B. The set B only. Set B only. Okay. The elements belongs to B only. So A union B is the element. So the element which belongs to A or B are both. So therefore here, so this is not data. So this is not data. Okay. So A intersection C. So here A intersection C is equal to which area? So A intersection C is equal to this area. Intersection of B is this. So therefore this is not belongs to A. Intersection with B, so we are not shading here. Okay, so therefore the fourth option, so B minus A into C. Okay, so this region is the whole elements which consisting A and C. So this region is A union C. So this region is A means. So therefore, so we need B only. So B only. Okay. So therefore, so this is B minus A means. So that means the element which belongs to B only. So this is the element which belongs to B only. So therefore we remove the element which are in A and C. Okay. So that is so B. So and minus of. So we are going to remove the elements in the set. That is so A union C. So then we get so B only. Okay. So that is the option. So this is the right answer. So B the shaded region we get. So A B minus A union C. Okay. And 20 question number 20. So let A and B and C are subset and U is the universal set. So if A is equal to 2, 4, 6, 8, 12, 20. Okay. This is set A and set B is 3, 6, 9, so 12, 15. And set C is equal to 5, 10, 15, 20. So and U is a set of all whole number. So U is set of all whole number. So U is equal to set of all whole numbers. Okay. So then the correct Venn diagram is here. So they are given so 3 Venn diagrams. Okay, and one more option is D, none of these. So which of the following is right answer? Okay, so see here. So in the option A, so what they given? See here. Okay. First A observe the set A. Okay. Yes, set A, set B, and one more is set C. So this is A. Okay, and this is B. And this is set C. Okay. So here, first this is the 6th element here, and here 20, and here 15, and 2, 4, 8, 12. Okay. So and 5 and 10 is here. Okay. 3 and 9 is here. Okay. So observe the set A. So 2, 4, 6, 8, 12, 20. Yes. Set A is right. Okay. And observe set B. So 3 is there, 6 is there, 9 is there, 12 is not belongs to here. So 12. So in this diagram, so 12 is not belongs to B here. Okay. So therefore, so option E is not correct answer. Okay. So here there is no element 12, but here 12 is the element of set B. So but here in the Venn diagram 12 is missing, so therefore we cannot take this option. So therefore option A is not right answer. So next we shall move to option B. Okay. So option B. So the diagram is options B. So 2, 4, 6, 8, 20, 6 and 12. Okay. So now observe. So 12 is they are taken here. Okay, 12 is taken here. Since 12 is belongs to both the set. Okay, is it clear? So now observe. Set A is right 2, 4, 6, 8, 12, 20. Right. And set B is 3, 6, 9, 12, 15. Set B is also right. And set C. So 10 is 5, 10, 15, 20. Okay. So an intersection is also right. So observe an intersection. A intersection C. So A intersection C. The common elements in A and C is 20 only. Okay. So and B intersection C. The common element in B and C. Is B and C. So C. So this is the common element in B and C. Yes, this is also right. And the common element in A intersection B. So 6 is here, 6 is here, 12 is there, 12 is here. Okay. So therefore, so options B is the right answer. Okay. So similarly, what about option C? So in option C, CA, so 15 is an element of set B. 15 is there. In option C, okay. So in option C, 15 is an element. 15 is an element of B. So they are not taking here. So they write here 15. In option C, so 15 is an element. 15 is an element of B. So but here there is no 15. So therefore there is also not right answer. Okay. So next we shall move to the question number 21. Okay. So let A is equal to consisting the elements. So x belongs to n and x is a multiple of 3. Okay, and t is equal to, so x belongs to n. So x is a multiple of 6. Okay, multiple of 6. So then a minus b. So then a minus b is equal to. Okay. So see here, this is a multiple of 3. So therefore this can be the as. Okay. So and so on. Okay. So this is multiple of 3. So similarly, so natural number consisting and so on. Okay. So this is the set B. Multiple of 6 is that what? 6, 12, 18, 24 and so on. So and x is a multiple of 3 and x is natural number. Set of all natural numbers. So therefore we have to write 3, 6, 9, 12 and 15 so on. Okay. So we need to find a minus b. So a minus b is the element which belongs to a, not belongs to b. Okay. So a minus b is the element which belongs to a. Okay. And x belongs to a and but x does not belong to b. X does not belong to b. So this is nothing but and this is nothing but. So see 3. 3 is belongs to a, not belongs to b. So therefore we are going to write 3 here. And 6. So 6 is belongs to both. So therefore we are not going to write here. Okay. So negative. And 9. Yes, 9 is belongs to only set a. So 9. Similarly, 12 is belongs to both. 15. Okay, 15. See it. So this is belongs to the set A only. That means element belongs to A, but not belongs to B. Okay. So therefore, so 15 and so on. So this is the set A minus B. Okay. The element which belongs to A or belongs to B. Okay. So option is what? So option 3 is the right answer. So next question number 22. Question number 22. So if A is equal to x such that x square is equal to 1 and b is equal to x such that x to the power of 4 is equal to 1. X to the power of 4 is equal to 1. So then A symmetric difference between B, which B is equal to option A is so I minus I. Okay. Option B is minus 1. Option C is minus 1 plus 1 I minus I and D is answer. Okay. So which is the following is the answer. So symmetric difference. So see here. This is the word symmetric difference. Symmetric difference. Symmetric difference of A and B. A and B. This is the word A. So B. So this is read as symmetric difference of A and B. Okay. So this is nothing but. So A union B. A minus B. So union of B minus A. So this is the symmetric difference. So A symmetric difference of A and B is nothing but. So A minus B. So A minus B is union union of B minus A. That is the symmetric difference. Okay. So first, what is A and what is B is. Okay. So the given set A is in the form of rule method. So we are going to write it in the form of Roche form. That is, we are going to list all the elements in the set A. And similarly, the set B consists of the element x such that x to the power of 4 minus 1. So this is also in the form of rule method. So we are going to write it in the Roche form. So that is, so A consisting the element. So that is, if this is possible, x square is equal to minus 1. So it is possible, and if x is equal to 1 and x is equal to plus 1. Yes, it is clear. So minus 1 whole square and plus 1 whole square both are same. That is 1. Okay. So B, so set B is, so x to the power 4. Actually, this is the fourth equation. Okay. So there is one chapter in your first PUC, that is complex number and quadratic equations in that chapter. So we are going to learn fourth equation. So is the limit. So there is one number I square. Okay, I square is the limit minus 1. I square. Then we are going to define one imaginary unit. So I square is equal to minus 1. I square is equal to minus 1. So therefore, so here the possible elements are, see here I square is equal to minus 1 is the limit. I square whole square is again minus 1 whole square. This is plus 1. So fourth. Okay. So that is, so minus 1 plus 1 and I so minus 1. So these are the fourth equation. Okay, imaginary unit. I is an imaginary unit. Is the term we are going to define. I is an iota. I square is the minus 1. So there is one new concept. So it is introduced in the first PUC, that is complex number system. So this is the biggest number system. So in that chapter we are going to learn that. Okay. So just say B is equal to I, 1 minus 1 I and minus A. So therefore A minus B. So A minus B, it belongs to A only. Element which belongs to A only. That is the set. This is the set. And B minus A. The element which belongs to B only. Element which belongs to B only is the limit. So I and minus A. So I and minus A. Is it clear? So we are going to union of this. So that is one side union with y minus A. I minus A. Okay. So union is the element which belongs to either A or B or both. Okay. So the element I minus A. Okay. So this is the required section. So that is the symmetric difference of the set A and B is I minus A. So therefore option A is the right answer. So this is not right. So this is A in B. Okay. So this is not right. So therefore option A is the right answer. Okay. So next question. So there is a inverted things is there in the question number 22. So that is, which of the following is incorrect? So both 1 and 2, and option B is only second, option C is not. So that is printed mistake. Okay, so remove it. So then next one is, so 23, question number 23. If A, B, C or three sets, so then A intersection of A union B. A intersection of A union B. So option is A union B intersection of A union C. Option B is A intersection B. So intersection of A intersection C. Option D is so A intersection B. So union of A union C. And D is option C, A, B, C. D is A intersection B. So union of A union A intersection C. So already distributive property. Okay. So you know that A intersection of A union B. Okay. So is nothing but, so this is the by distributive law. So this is A intersection B. A intersection B. A intersection. So C A intersection of this is A, intersection A. So just I want once again B, A intersection B. So this is A intersection B. Okay, unions. Okay. A intersection B union C. Okay. So see here by distributive property. So this can be written as so A intersection B union of so A intersection C. Okay, by distributive property. Okay, so therefore the right answer is D is the right answer. So A intersection B union of A intersection C. Okay, so this is the right answer. Okay. And next question number 24. So A and B are two sets, then A minus B union of B minus A union of A intersection B. So is equal to say A is only A. So B is so A union B, C is A union B whole dash, and C is and D, and option D is none of these. So see here. So A minus B union of B minus A union of A intersection B. Okay, so it is better to go through the Venn diagram. Okay, suppose I am taking here A and here B. Okay, so this is the set A and this is set B. Okay, set B. Okay, so A only is that this region is the only A. See, so this is the only A. Okay, so only A is the limit. So A minus B is the limit. So this is A minus B is the limit. So this is A minus B. So this is the A minus B. Okay. B minus C is the limit. So this region is so B minus C is the limit. B only. So this is A only. Okay. So this is B only. Okay. B only. So this is A intersection B. So this region is A intersection B. Okay. So this region is A intersection B. Okay. So then we need to calculate A minus B union B minus A in A intersection C. Observe here. So we are going to union this area. Is the limit or not? So this is the limit A union B. So this is the limit. So A only, union of B only. So B only, union of both A and B. Okay. So is nothing but what? A only, this is B only, and both A and B. So this region totally we are going to take the complete shaded region. So is nothing but. So this is nothing but. This is nothing but what? This is nothing but A union B. Is it clear? So therefore option A union B. This is A union B. Whole dash. Okay, this is whole dash. So therefore option B is the right answer. Okay, option B is the right answer. Okay. So one more question. So question number 25. See here, U is the universal set and A and B are the subset of U, and N of U is here. So N of U is here given, that is defined, and N of A is given, so that is option D, and N of A union B whole dash is given, so that is 8, and N of A intersection B, so which is equal to 6. Okay, so this is the given data. So then we need to find N of B. So N of B is equal, and N of B minus C is also question mark. Okay. So are respectively given by the ordered way. Okay, that means the number of elements in the set B and number of element in B minus C are given in the order way. In the form of order way. Option A is 6, 2. Option B is 8, 2. Option C is 8, 8. Option D is so 16, 8. So see here. So N of B minus C is the element which belongs to B only. Okay. So that is N of n of b minus a is nothing but the element which belongs to b only. So here, so by using this data, so we are going to take one formula, that is n of u, that is going to n of u, okay, so minus of n of a union b whole dash plus n of a plus n of b. See here, so I will explain this with the main time. See here, so this is the universal set, so this is n of a, so this is n of b, okay, so n of a, this is n of a. Is it clear? So n of a union b whole dash. So this region is n of a union b whole dash. Okay. So this region is n of a union b whole dash. Okay. This region. The total region is n of b. So number of elements in universal set. Okay. So A union B whole dash is this region, okay, and n of A is only this region. So we need to calculate the region. So n of B minus A. So this is nothing but B minus A is the element which belongs to the set B only. Okay. So therefore, so we are going to subtract. Okay. So here A minus B is the element which belongs to the set B only. So therefore we are going to calculate this by using given this data. So we are going to subtract n of A union B whole dash. So it consists of all elements n of A union B whole dash. Okay. So therefore we are going to subtract n of A union B plus n of A is this element which belongs to. So n of E, number of element in E, including this area. Okay. So that is, so n of E is nothing but what here? 25. 25. So minus of n of A union B whole dash is nothing but this is 8 plus n of A is nothing but what? N of A. So n of A is given is 15. Okay. So therefore, so it is nothing but 24. So 24. This is the limit. So this is the n of b minus a. So n of b minus a is limit. So this is 2. Okay. So that is 22 minus 23. So this is 2. Okay. So then we need to find out the number of elements in b. So this is 2. This is 2. Okay. So n of b is the limit. N of b. You know that. So n of b minus a is equal to n of b minus of n of a. We have a formula. N of b minus a is n of b minus n of a is b. Okay. So here we need to calculate n of b. Okay. So therefore, so n of b is equal to, so n of b minus a, n of b minus a. So plus n of a is b. Okay. So this is the matter. N of b minus a is what here? So b minus a is 2. This is 2 plus n of a expression b is 6. So this is 8. This is n of b. Okay. So therefore n of b is 18. N of b is 18. So therefore the number of elements in n of b is 8 and n of b is 2. So therefore option. So which option is the correct answer? Option B is the right answer. Okay. So in the next sessions we are going to discuss some more problem.